Hello everybody. Today we are going to be discussing how we can keep a consistent world state between our players using voxel play and mirror. Imagine we have these 4 players here, all in yellow, and they all change the world. How can we make sure that these changes affect every other player the same? Well, we want a central place that will take care of it. This is usually the server. So how would that look like? Well, one client, for example, would set a command to the server, and once the server gets that command, receives it, it would apply changes to the world, and an on-chunk change event would be triggered. Then we can use this trigger to capture this data and send it back to the clients using an RPC command. And that's what we're going to do today. So let's go back into Unity. Now, I have already created a world state object, and I have created a world state network behavior, and I have added it to the object, which also automatically added a network identity component to the object. So let's check out this world state script. If we go here, you see I have added mirror and voxel play already, and I have already registered the voxel play environment variable. And here are two new start methods, which are given to us by mirror, and this allows us to do things differently if we are a server or if we are a client. We actually do want the environment instance to be assigned in both cases, but what we want the server to only be able to do is register an on-chunk changed event. So if we go into our SDK, we can see in the events, under chunk related, we can see the first one is voxel chunk event on chunk change, which is exactly what we want. Now here we have an example of how this works, and we register the callback here with an environment.onChunkChanged, and here is our method name. So let's just copy paste this and add it here to the server, so only the server can register these events. And let's add our method, and let's rename it. So let's call this onChunkChanged. Method. As I explained in the beginning, we need to be able to send chunk data to the clients. But before we are able to send it, we need to be able to get it. How do we do that? Well, thankfully, in the voxel play SDK, we have this handful getChunkRawData method, and it takes an input of a chunk and it gives us out a byte array. Before we are able to use this though, we need to be able to register our byte array, and we do this with this method here, getChunkRawBuffer. So we need to register an array and we need to give it a buffer. So let's go here and create byte array chunk data. And now here in the start we have to get getChunkRawBuffer. So now in the onChunkChange method, we can use this to get the contents of the chunk. So if we check our method here, it returns a type of int, so we are going to use that, and we're going to go int length equals env getChunkRawData, pass through the chunk and pass out the chunk data. So if you remember last time, we created some client RPCs, well, one actually, and here's the code for that. So we have client RPC exclude owner equals true, and then we need to create a void that uses the prefix RPC. So public void RPC set chunk data, and we want it to have inputs of the position of the chunk, vector3 chunk position. We want it to have the data, so chunk data, and we want it to have the length, so incoming length. So we can call that RPC now by going RPC set chunk data, open the parentheses, and give it our chunk position, the chunk data, and the length. Now, in the RPC, we are not doing anything yet. We want to be able to take this chunk data and set the data. So, in the methods here, we can see that we have set chunk raw data. So, let's copy paste this. And we go environment, set chunk raw data. And we have passed through the chunk position because we can't pass the chunk through the RPC because it's not a recognized type. So we are going to use the chunk position to get the chunk we want. So environment, thankfully VOXEL Play allows us to do that. Get chunk, and we pass through the chunk position. And we set the force creation flag to true so that it is created. And now we just set the chunk data and the length, incoming length. So that sets the data, but if we test it, we're going to see that the chunk might not redraw correctly every time or expect us to do another change until the changes appear. So in this case, we need to force a chunk redraw. And we do this, there is a method that is provided, and we have chunk redraw. And it requires a chunk, and it has a flag for include neighbors, which includes 26 surrounding chunks, which we're not going to be using, so that would be false. But let's see about our chunk. So here at set chunk raw data, we get our chunk using the position and forcing its creation. And that's not going to be good enough. We want to be able to create a voxel chunk, current chunk, and say this is equal to environment get chunk. So we can reuse this. So let's go environment, chunk, redraw, pass through our current chunk, and we have some flags here. So it says bool include neighbors, we want that to be false. And bool refresh light maps, we want that to be false. And the last one, which is refresh mesh, we want to be true. Sorry, true. Okay, so that should be it. Of course, okay, I have forgotten to assign the chunk data. So chunk data equals environment get chunk raw buffer. Okay, so that should create the buffer. Okay, now if we save this, the above here is a server and the windows below are clients. So if I'm in the server and I do changes in the server, they propagate to the clients automatically. So you can see we won't be passing any events. So you can't see the particles, but the world is changing. And you can see it's happened for all the clients. So let's drop a grenade here. And you can see that when I throw a grenade, it automatically appears for all the clients. And you can have some fun with that. So, thanks for watching, guys, and I hope this helps you further progress your VOXEL Play multiplayer projects.